Hello students, and welcome to today's lesson on holes and horizontal asymptotes. Our objective today is that we will analyze holes and horizontal asymptotes using journal notes and practice problems. So, last time we left off, we had seen a case where we had something that divided both the numerator and the denominator, right? So it was one of these factors that caused both the numerator and the denominator to go to 0. And we said that that did not cause a vertical asymptote. So we're going to see what that situation will cause now. So a hole, or a hole discontinuity, occurs when the same factor exists on the top and bottom, or the numerator and denominator. So it's when the same factor exists in the numerator and the denominator. And then horizontal asymptotes are going to be horizontal lines which a function approaches but never touches. So holes we see are going to be eliminated whenever we're reducing the expression. So if we see something like this, so f of x is equal to x plus 4 times x minus 1 over x minus 2 plus x plus 4, then we see that we share this factor here in the numerator and the denominator. So what will happen is that those are going to eliminate each other. So x plus 4 and x plus 4 will eliminate each other, and we'll be able to reduce this down to x minus 1 and x minus 2. So what this means is that while the function could be modeled using this expression here, there is one particular point where there will be a hole in the graph, and that hole will be at x is equal to negative 4. So that's where my hole will exist, is that x is equal to negative 4. And what we're going to see is that there's actually a 6-step process that we can use to find any holes of an expression. And this 6-step process is actually part of just finding asymptotes in general. So if we're given a general polynomial, just like what we see in example 2 here, and we're trying to determine if there are any holes or determine any asymptotes, then we follow this process to be able to find the holes. So first what we want to do is we want to factor the top and bottom. The numerator, I'm going to say top and bottom for numerator and denominator because they're a little bit shorter to spell. So we're going to want to factor those, then reduce. So reduce any terms that you can. So a hole is formed when a factor is eliminated from the denominator. So that's going to be our step 3. Then to find the x-coordinate of the hole, you're going to set eliminated factor equal to 0 to find x coordinate. So we're going to set the eliminated factor equal to 0, and then that will find our x coordinate for it. So then what you'll do is you can find the y value of the hole by plugging in the x found in step 4 to the reduced equation. And then finally, your answer is a point. So your answer will be written as a point. So a hole is literally that. It's a point which does not exist on a graph. So let's go ahead and go through this six-step process using example 2 as a guide. So the first thing that I want to do is factor the top and bottom. So for the top, I'm talking about x squared minus x minus 6. So I'm looking for two numbers that will add to make -1 and multiply to make -6. So I'm thinking that it's going to be x minus 3 and x plus 2, because those are two numbers that will add to make -1 and multiply to make -6. And then I've got x squared minus 7x plus 12, so I'm looking for two numbers that will add to make -7 and multiply to make positive 12. So I'm going to say x minus 3 and x minus 4. All right, so I've factored. So that was step 1. And now I'm going to move on to step 2. So now I want to reduce. So what I see is that I have this term here, x minus 3 and x minus 3. So those are going to go ahead and cancel each other out. So now I'm left with x plus 2 over x plus 4. So now I've reduced. Then I move on to step 3. A whole is produced if a factor is eliminated. So the factor which I eliminated was x minus 3. So step 4 is to set it equal to 0. So x minus 3 is equal to 0. And then we want to solve for x. So we find out that x is equal to positive 3. So that's where the whole will exist, is that x will equal positive 3. Now what I want to do is take that x value and I want to plug it in to my reduced equation. So I want to plug 3 into this equation for step 5. All right, so now in step 5, I'm plugging in 3. So 3 plus 2 will give me 5. And then 3 plus 4 will give me 7. So now 5 over 7 is equal to my y value. And so for step 6, I write it as a point. So my point will be 3, 5 over 7 is a whole. So this is a point where our graph will never exist. So it's like this empty space that we have. So our answer here is that the graph will be 3, 5 over 7 is a whole. So at first this process seems like a lot, right? We had to factor, we had to reduce, the whole is eliminated, or the whole is what happens if a factor is eliminated. But really, in my opinion, the hardest part is step 1, right? Is to factor. So we're going to practice a lot on factoring and making sure that we know how to factor a polynomial. That'll be the hardest part of finding our wholes. Eliminating the factors, easy. Plugging in numbers, easy. But actually factoring these is what's going to be difficult here. And we'll have a couple of practice problems for this on our worksheet. So just be aware that those will pop up every once in a while. Finally, we're going to talk about horizontal asymptotes. So horizontal asymptotes, as we defined, are those horizontal lines which a graph will approach but never quite touch. And there are 3 different conditions for horizontal asymptotes. So for horizontal asymptotes, luckily, all we have to focus on is the very first term in the polynomial. So I have x cubed plus x plus 1 over x cubed, 2x cubed plus 2x plus 5, right? So as far as a horizontal asymptote goes, all I need to focus on is this first pair of terms here. So I just have to determine if the exponents match. If they don't match, and if they're not matching, then it'll determine whether or not there's a horizontal asymptote or not. So our first condition is going to be bigger on bottom 0. So if I have a condition like this where I have x cubed over x5, and then I've got all this, maybe x squared plus x squared. So I'm looking at the very first term in each one. So I have x to the third, and I have x to the fifth power. And if it's a larger exponent here, then we're going to say that the horizontal asymptote is y equals 0. So if you have a condition like this where your exponent is larger in the denominator, then your horizontal asymptote will be y equals 0. So then we have our second condition, bigger on top, none. So if you have a condition like this where you have x to the third over x squared, then what we're going to say, or plus, let's say plus x and then plus 3x squared, right? So if the leading coefficient, or I'm sorry, if the leading terms here have a larger exponent on top than on bottom, then no horizontal asymptote exists. So there won't be a line which it approaches but never touches in the horizontal direction. And then finally, we have that if the exponents are the same, divide the coefficients. All right, so let's say that we have 5x cubed plus 2x over 3x cubed plus x squared, right? So if we have a case like this where the exponents are the same, then my horizontal asymptote will be given by dividing the numerator by the denominator. So in this case, y is equal to 5 over 3. So those are my three different cases. And a lot of the times what I'll say Bobo botany eats DC. And that's just kind of like a memory device to help you remember all these conditions. So bigger on bottom, 0. Botany, bigger on top, none. And then eats DC equal, or exponents are the same, divide coefficients. All right, so let's see an example of eats DC. So again, we're just focusing on these first terms, right? We see that we have a cube and a cube, therefore our leading coefficient is going to come into play. So we know that y will be equal to 5 over 2. That will be my horizontal asymptote. And again, the difficult thing about these is going to be making sure that we're using the appropriate information. So here, the great thing about horizontal asymptotes is that you don't even need to do any factoring to find them, right? So in this case, I have the leading exponent here is 1, the leading exponent here is 2. So bigger on bottom, 0. So I know immediately that y is equal to 0 because my exponent was larger on the bottom than it is on the top. Over here, we have bigger on top. So this is bigger on top, none. This was bigger on bottom, 0. So y is equal to 0. And then bigger on top, none. So there is no horizontal asymptote. And then finally, we have our last example here. So we have 2x over x minus 4. Well, I've got my leading term up here. It's a 1 up there. So it has a leading exponent of 1 here and 1 here. So they're equal on top and bottom, so we're going to divide the coefficients. So we say y is equal to 2 over 1, or we can say that HA, the horizontal asymptote, is equal to, y is equal to 2. So that's my horizontal asymptote. All right, and then finally, let's talk about intercepts. So our y-intercept, you set the x value equal to 0 and evaluate the function. So you would just set equal to 0, so 0 minus 4 over 0 minus 2. And then that's going to be f of 0. And we see that the y-intercept is going to be the point 0, comma, and then negative 4 over negative 2 is positive 2. And down here, this will be our x-intercept. I apologize, I missed that line. So that's going to be your x-intercept. And what we're going to do is we're going to set the numerator equal to 0 to solve for that. So we say 0 is equal to x squared minus 4. And then what we'll see is that we have positive 4 is equal to x squared. And then we will take the square root of both sides. So we get x is equal to 2 in this case. Or x is equal to negative 2, because negative 2 squared would also give me 4. All right, so those are going to be the two x-intercept locations, and that makes sense to us because we have a couple of different branches that we might have. All right, so your reflection for today is, how are holes different from asymptotes? And then your assignment is to find the horizontal asymptotes and the holes in your asymptotes practice. All right, thank you for listening. Have a wonderful day. Let me know if you have any questions.